Teaching nature of science using the inquiry instructional strategy. This is probably the most effective one. This draws upon, highlights students' current experience that's shared among their classmates, that connections can be drawn to whatever the instructional objectives are with this shared experience, as opposed to, let's say, teaching using the history of science. So with that said, this is probably the most effective strategy, and one where we pique the student's interest using a perhaps some sort of a topic that generates a lot of interest, an event or an observation that kind of baffles their current thinking. This might be, in this clip here that I'm making for you, is best to be accompanied by the inductive lesson swirly milk activity, where they see this discrepant event of this milk and food coloring and this kind of tie-dye reaction that happens within the milk, and they're left with generating a lot of questions about what would happen if I used a different percentage of fat of milk, what if I used water, what if I used a different type of detergent, what if I used all 4 food colors at the same time, what is the rate of dispersion among the different food colorings, all kinds of different questions that are generated. And this can be described using the Heron scale as far as where we might go from here. In the level 0, this is typically, well, this is what we call the cookbook lab, where it's just following a recipe that's given. This is not what we want to do. This is really not inquiry. In the case of a level 1, we might give them the question, and that might be done in this form with the milk activity by generating a large list of questions that the students come up with, and then the teacher directing students towards one of the questions, or even just explicitly stating we're going to pursue this question. Then the teacher at this point may give them the procedure, or in the level 1, or in the level 2 to give no procedure at all, and have students generate that. And of course, in both of them, there's no solution. Or in 3, students are able to pursue their own problem or question generated from the list, such as in the milk activity. So some students might be interested in looking at the fat content and how that affects X. And other students might be more interested in the different detergents, what different brands cause different reactions. But in either case, one thing that can be done, like in this swirly milk activity, where students make these observations, and some of these will end up being inferences that can be moved over into the other list, and there's an excellent opportunity for nature of science to identify 2 different aspects of nature of science. As I mentioned before, they might generate a bunch of questions. We may direct the class to a single question, or they can pursue several questions depending on what level of inquiry you'd like to pursue. In the swirly milk activity, one of the instructional objectives is to look at what makes an experiment an experiment. And so we look at several different criteria, and this leads students to attend to things like fairness, to testing only one variable at a time, to realize that they're looking for a cause, and to formulate a hypothesis. And this might be one hypothesis that could be formed with the swirly milk activity, such as all 4 colors of food coloring respond the same way to the detergent tip toothpick submerged in the center of the milk. So it's very clear what my be pursued in the hypothesis and what the alternative, the null hypothesis, might be. And then here is a drawing of this hypothesis. Though they might have just one colored detergent at the center and be measuring the rates, such as this in this second group hypothesis, the mixing action will continue as long as the detergent tip toothpick is in the milk. And this group formed a table, and you can see here what information was obtained and what conclusions might be drawn from this.